and welcome to this Maths prediction for the OCR Paper 6 Higher Tier Maths GCSE. Enjoy! Hi and welcome to this prediction from Maths for the very last paper. So this is going to be filmed before any of the papers, so please bear that in mind when you watch this. The papers are very condensed, and so it's very difficult to set new videos out. But this paper is still based on all the previous exam paper questions that have come before, including the June and November ones in previous years. And we look at what comes up loads and what is long overdue coming up. Don't also forget you can do this online by clicking here, and it's completely for free, and you can sign up for free and save your scores so you can track your progress with this. On our site it's also the topic busters, which are very focused on specific topics, and there's all the Maths GCSE topics there, so you can practice a specific topic rather than the more generalised. You can also do the revisionator, which will just blast you with random questions. It normally takes about 10 to 15 minutes to complete. So if you've got less time or you want to do something regularly every night, then that's a really good idea. Don't also forget that the online version is random numbers. So the methods and questions will be the same as this video, but the answers will be different, allowing you to do multiple times. If you like this video, please click like. And if you want to see more from us, please click subscribe. Also, just bear in mind that this is a revision tool. Please do all of your normal revision as well. I hope you enjoy this video. So this question says there's a tennis tournament being played where each player plays each other once. And there's multiple ways of doing this. One of the ways is listing out all the different combinations. But this question only asks for how many tennis matches are being played. So you don't need to list them out, and sometimes you will need to list them out. This one you don't. So let's start off with a lyre. A lyre has 4 people that they're going to play against. William, Paul, Samantha and Christine. William, well, we've already counted a lyre's match with William, so William only has 3 left that he can play. Then Paul we've already counted his match with the other 2, so he's only going to play Samantha and Christine, other than his matches we've already counted. Samantha, well, Samantha's only got Christine left to play after we counted all the other matches. And Christine, well, Christine's matches have already been counted so far. So, we've got the 4 matches Elia's going to play, 3 matches that William's going to play, not counting the one we've already counted from Elia, plus the 2 Paul's going to play, plus the other one that Samantha's going to play. So 4 plus 3 is 7, plus 2 is 9, plus 1 is 10. So in total there are 10 different matches going to be played. Okay, so we've got a scatter graph question, and the first question asks us just to plot the information from the table into the scatter graph. So we've got ice cream sales at the top and temperature at the bottom, which is not kind of the same way around as on the graph, so we've just got to be careful. So the ice cream sales are 46, which is here on the scale, and the temperature is 31, which is here on the scale. And just check that you're looking at the scale correctly. So we're looking about, let's have a look, about here. Okay, next one, ice cream sales 40, which is here on the scale, and temperature 34, which is here. So we've just got to be careful, and it's about there. So those are the 2 plots that we want to take. Next question says, on another day had an average temperature of 45 degrees. Use the scatter graph to estimate the sales of the day. Now, you need to get used to just drawing a line of best fit to any scatter graph that you come across. You will have to do it, okay? So just do it. Just, even if it doesn't ask you to, just draw a line of best fit. Now, a line of best fit is just a line that follows all the data like that. You should have roughly the same amount of data top and bottom, but it doesn't matter if it's not perfect, okay? So let's have a look. So we've got average temperature of 45 degrees. So we're going to draw a line up from 45 degrees, which is about there. And we're going to draw, oh, the line didn't come up. So let's draw that line there. It's refusing to come up for some reason. Let's try another one. There we go. Let's try another line. Okay, let's do it the old-fashioned way. Okay, and then we draw a line across from where it's the line of best fit. Now, to me, that looks like about 55. But if you had the same question and you came up with a different answer of 54 or 58, it still can be correct because you might have drawn a slightly different line of best fit. Okay, so don't worry if you sit down next to someone, do the same question and get a slightly different answer. Just draw the lines, straight lines, unlike mine, onto your diagram to show the examiner that you worked it out. So we've got 55 sales we're predicting. Now, what do we notice about this? Well, look at where all the data is. All the data is here, and yet we're estimating outside the range of the data. Okay, it's called extrapolation where you do that. So the problem with that, if you imagine we do a graph of height against age, so we have age at the bottom and height up the side, then when you're very young, you grow quite quickly. And if someone extrapolated your data and said, oh, okay, well, that growth is going to continue, when you're 80 years old, you're going to be 20 foot high. Well, that doesn't make much sense. It's because we're quite confident with down here, because we've got data for that, but we're not very confident with this bit here. We don't know whether the trend continues. Now, with ice cream sales, if it's ridiculously hot, no one's going to leave their house. They're all going to be sitting inside with their air conditioning or sitting in their car with their air conditioning. So we know it probably won't continue. So if you just say that the estimate is outside the range of the data, and if you want to really impress the examiner, then you can use the word extrapolated. It's been extrapolated. Okay, factorize means put it into brackets. So looking at the first one, there's a t I can divide out of both of them, so I put t on the outside of the bracket, but there's no number because 7 and 5 don't have anything that goes into both of them. So I think, what do I times t by to get to 7t squared? Well, it's going to be 7t. And what do I times t by to get to 5t? Well, it's just going to be 5. You can check your answer by expanding the bracket, it makes 7t squared plus 5t, which it does. Next one, w is only in the first term, so I can't divide out the w, but there's a number I can divide out of both of those. Now, I could pick 2, but actually 4 is a better number because it says factorize fully, which means I need to take out or divide out the 4 rather than just the 2. So 4 on the outside. What do I times 4 by to get to 12w? Well, 3w. And what do I times 4 by to get to minus 8? It's going to be minus 2. And again, I can expand that to check it. Right, the last one, there's a number and a letter. So I'm thinking the number of 16 and 24 would be 8, and the letter would be A. Okay, so there's two things that we're dividing out this time. So I'm going to have 8a on the outside. So I figure out, what do I times 8 by to get to 24? Well, that's 3. And what do I times a by to get to a squared? Well, that's going to be a. What do I times 8 by to get to 16? 2. And what do I times 2 by to get to 16a? So it's just going to leave it because the a is on the outside of the bracket. So a to a times 2 is 16a, so I don't need an a there. So for this question, we just need to remember the area of a circle. Now the area of a circle is going to be pi r squared. Now that's the area for a full circle, my dodgy circle there, but we only have a quarter of it. Now if you have a look, that length there, the 22 centimeters, is going to be the radius of a full circle if I drew the circle properly. So we know what the radius is, And all we do is we times it by the fraction of the circle we have, which is going to be a quarter. So it's going to be pi times r, which is 22 squared, times a quarter. So I'm going to do that on my calculator. Pi times 22 squared. And then you can press equals and then just divide it by 4. That's the same as timesing it by a quarter. And the answer I get is 380.1327 blah blah blah. And so to 2 decimal places, that's going to be 380.13. First thing we need to realise with this question is, which transformation is it? Well, you have to go through the 4 transformations. The first one I think of is, has it rotated? Has it spun around? No, it hasn't. Second one, is there a mirror image of it? No, they both look the same, so it's not been reflected. Has it grown or shrunk at all? No, so it's not an enlargement. So that leaves transformation. Translation. Translation. Now, translation just means we've moved it, and that's perfect because we have just moved A to B. Now, the second thing to realise is we are starting at shape A and we're going to shape B. Now, with translations, to describe them, pick the same point on both shapes. I always pick the top left if it's available. Then, what we want to do is work out how far left or right I have to go from A to get in line with B. And I do this with jumps, and the reason we do this with jumps is I never get the wrong answer when I do jumps. So 1, 2, I need to go 2 left, so 2 left, and let's have a think, how much up do we have to go? So 1 jump, 2, 3, 4, so 4 up. Now the way of showing translations is by using vectors, and it sounds fancy, but it's just putting this information here between a bracket. The number at the top of the bracket is how far right it's gone, and the number at the bottom is how far up it's gone. Well, let's do the number at the bottom first. So translation by, there's different words you could use there, and the number at the bottom, well, it's gone 4 up, so it's just a 4 there. Now here's a problem. This is how far right it's gone, but it's gone 2 left. Well, we just simply put -2 right. Now be careful, don't ever put a fraction line between the -2 and 4. It's not a fraction, okay? So don't ever put the fraction line in. These questions are just based on a few rules of indices. The first rule says that if you've got 2 powers with the same base, which these two do because they're both A, you add the powers. Now if you think about it, A squared is A times A to the power of 6 is A times A times A times A times A times A. So in total we're timesing A by itself 8 times. So it's A to the power of 8. The next rule says if you've got a power inside the bracket and outside the bracket, you times them together. So it's M to the power of 3 times 6, which is M to the power of 18. Now this last one's a little bit more complicated, and I'm going to write it out so I've got a bit of a larger one to play with. Okay, first thing I focus on is the number. Now 55 over 11, so I know that 55 divided by 11 is going to be 5. 55 divided by 11, that's all we've got to do. And the reason we can do that is there's only one term at the top and one term at the bottom. Term is defined by, whether there's a plus or a minus, and there's no pluses or minuses here. Okay, so next one, we've got the r's that we want to divide. So we've got r at the top and an r at the bottom. Now this r at the top is technically r to the power of 1. Now when we do r to the power of 1 divided by r to the power of 8, which I'm going to write out down here so I can show you, you take away the powers. So when you times them, you add the powers. When you divide, you take away the powers. So that's r to the power of -7. Okay, now we're left with the s's. And it's the same thing with the s's. This time we're doing s to the power of 15 divided by s to the power of 8. So it's going to be s to the power of 15 take away 8, which is 7. So my answer would be 5 r to the power of minus 7 s to the power of 7. Okay, to convert from standard form, you just write the number down, and this here, the power, will tell you where to go. So if the power is positive, then you go to the right. If it's negative, then you jump to the left. Now since it's negative, we're going to jump to the left, and it's minus 6, so we're going to jump 6 spaces. So 1, 2, 3, 4, 5 and 6. So the decimal point will now be here, and you fill in all of the jumps with zeros. So one of the jumps is used by the 8, but all the other ones we fill in with zeros. And whenever you've got just a decimal point, you need to have something before it, so we put a 0 before it. So the answer will be 0.00000084. That would be the answer. So let's just count. There's 5 zeros and 5 zeros. Okay, to convert to standard form, you write out the number and you try and put a decimal place in to make the number between 1 and 10, but not including 10. So if I put it in here, that would be 72, so that would not be right. So I need to put it in here. Then you count how many times you had to move the decimal point to get it there. So the decimal point started at the end of the number, and we had to move it 1, 2, 3, 4, 5, 6. Okay, so the rule is that the number has to be between 1 and 10, which this one is. Now, if you had a big number, then the power of 10 will be positive. Now here we did have a big number, so it's going to be positive 6. On the previous one, we had a small number, 0.00084. I don't know if I said the amount of noughts that were there, and you can see that the power in the question was negative. So negative power of 10 is really small number, positive power of 10, really big number. This does turn up on the calculator paper as well. So if it does, you can actually just type in question A into your calculator and just write down the number it gives you. Now some calculators are smart and do things in standard form, so you might need to do it this method anyway. Alright, so we're asked to draw a frequency polygon, and the only error you're going to make with this type of question is figuring out what a frequency polygon is. Now, a frequency polygon is where you put little crosses at the points, and the points lie at the group's midpoint. So we've got our first group 0 to 10, so the midpoint would be 5. Next one is 10 to 20, so that's going to be 15. Then 25, then 35, then 45. So the first one's going to be at 5, and it's going to be 6 high. It's going to be like that. Next one's 15, 22. So 22 would be about there. 25, 59. So 59 would be right up here. 25. 35, 15. A little bit lower than that, but that's fine. 45, 4. Now we're only halfway done, and my points aren't exact because the screen I'm using isn't the most precise, but it's good enough. We're only halfway done because what we need to do is join these up with straight lines, so no curves needed. And when you join them up with straight lines, do not ever join up the last 2 points. You're not actually trying to make a polygon, okay? So don't ever, when you join them up, whatever, right? Don't ever draw this line here, okay? That's not a good thing to do, so make sure you don't do that. Okay, and that's it. So midpoints, crosses, and then join them up with straight lines if you're asked for a frequency polygon. Alright, so it says that the town council is saying that over a quarter of the stores get over 30 customers. So we're going to see whether that's right. So over 30 customers would be these two groups here, so 30 to 40 and 40 to 50. So that is 19 altogether. So that's 19 out of, and let's add all the rest up, so 6 plus 22 plus 59 plus 15 plus 4, out of 106. It didn't say it in the question. So it's 19 out of 106, which as a decimal, 19 over 106 be 0.179 to 3 decimal places. So what I would say in the exam is no, because that is 17% or 17.9%. So it's less than 25%. And just write a sentence saying that yes, it's close, but it's not quite at 25%, because even rounding up to the nearest percentage, it's 18%, which is 7% lower than 25%. So just make sure you write all of the numbers in an answer that answers the question. Okay, so we're asked to find the length of the line AB, and the way of doing this is you work out how far across you go and how far up you go, and by doing that you create a right angled triangle. So we go 2 across here, 2 jumps across, and if you don't know that that was 2, let's just do a different method. So to get this other one, 1, 2, 3 jumps up, or you just know that it goes up to 4, down to 1, 4 take away 1 is 3. So it's a right angle triangle with sides 2 and 3, and we're looking for the third one. Now, the one opposite the right angle is going to be labelled as C. These two, it doesn't matter, I'm going to call that A and that B. We use Pythagoras' formula. So A squared plus B squared equals C squared. And A is 2, so 2 squared plus 3 squared, because B is 3, equals C squared. Let's put our lines in. So it's going to be 4 plus 9 equals C squared. 13 equals C squared. Square root both sides, and let's get my calculator. So square root of 13 is 3.6055 blah 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 equals C. So it's 2 decimal places, it's 3.61. Now be careful, sometimes it will say that it's done on centimetre square grid, so you might have a units attached. If you want to put units but it doesn't say any, you can just write 3.61 units. For these types of questions, always make sure that you show your working, show how you know something is something. So the way I would start this, and this is not the only correct answer, is I realise that these two are the same. So I know that 2y minus 50 equals 52. The reason I know that is that they are corresponding angles. Now, some of you might know that as F angles, but make sure you write the word corresponding, because they won't accept any other word. So I can solve this by first of all adding 50 to both sides. So that's 2y equals 102, and then I'm going to halve both sides. So y equals 51. So I know y is 51, so I now know that this angle here is 51 degrees. Now I know that this is 52 degrees because if you look at this, and I'll use a different colour, this angle here and this angle here are Z angles or alternate angles, or you can say that this 52 degrees here is equal to this here, which is also 52, because they're vertically opposite angles. So I know that this one here, and I could call it a letter on the diagram, so I could say C. I don't think there's another C, so C equals 52, and show the examiner, right, that's because, well, let's go for alternate angles with the original value. Okay, so we've got three sides, or three angles in a triangle. I've got way too many colours going on here. So to work out x, so x equals, it's going to be 180 minus 51 plus 52. So work out what 51 plus 52 is, and then take away from 180. And the reason is angles in triangle. Okay, so I know that 51 plus 52 is going to be 103, and therefore that's going to be 77 degrees. So my answer is 77 degrees. Okay, so we have a set of simultaneous equations, and I'm just going to start off by just writing them out to give myself a bit more room, because it's a little bit too small otherwise. So I'm just copying out the question. Now, there's a list of things we need to do for these, and there are different methods. I'm just going to go through the main one. The first thing is I need to get either the x's or the y's the same coefficient. So the number before them needs to be the same, ignoring signs. Now looking at this, and I'm going to label these A and B. Looking at this, if I double A, then the x's would become the same because they both have a coefficient of 4. So what I'm going to do now is I'm just going to write 2A. So I'm going to double everything in A. So double the 2x to make 4x to make the x's the same. Double the 5 before the y, so that's 10y now. And double the 24 to make 48. Now, next, I need to probably, and it's normally the case that if I write down B again, it just makes things easier. So I'm just going to literally copy down B underneath. Okay, so next I'm going to remind myself that I'm working downwards now. So I just put little circles around these to remind me I'm going downwards. And I need to look at the sign before the letter that I've made the same coefficient. So I'm looking at the x's and I'm looking at the signs before them. If the signs are the same, we are going to subtract. If the signs are different, we're going to add, and it's that simple. Okay, now the signs are the same because they're both positive, so we are going to be subtracting. So a minus there, a minus there, and a minus there. Okay, let's start. 4x take away 4x is nothing, which is good because it needs to be nothing. 10y minus 3y. Now 2 minuses make a plus, so that's 10y plus 3y, which would be 13y. And we've got 48 plus, because the 2 minuses make a plus 4, which is going to be 52. I'm going to put my lines in. Okay, next I need to do 52 divided by 13. And we're going to do both of these divided by 13. So we've got y equals, I think it's 4, so 4 times 13 is 52. So yeah, y equals 4. Then I'm going to pick one of the equations from the question and I'm going to substitute the 4 in. I'm just going to pick the top one. So 2x plus 5 times 4, because we know that y is 4, equals 24. And again, put my lines in. So it's 2x plus 20 equals 24. Take away 20 from both sides. 2x equals 4. Divide both sides by 2. Extend my lines a little bit. And x equals 2. Now if you've got time in the exam, you can check that that's right by using the second equation. So 4 times 2 is 8. 3 times 4 is 12, and 8 take away 12 is minus 4, so we know it's correct. So x is 2 and y is 4. Okay, so for the first thing to do with this question is to write it out twice. Whenever you square something, you times it by itself, and itself is the bracket x minus 15. And there are multiple ways of doing the next bit. I'm going to use the grid method for this one, and we put the first bracket at the top, so x minus 15, and the other bracket down the side, which is just x minus 15 as well, and we're timesing, so x times x is x squared, x times minus 15 is minus 15x, x times minus 15 is minus 15x, and then minus 15 times minus 15 is plus 225. Okay, then these two here will add together. So when we write our answer, it's x squared minus 30x plus 225. Now the really common answer to this is people thinking it's x squared plus 225. Okay, and that is wrong. Okay, students do that, and I'll put a big cross through it. Students do that because they don't understand that you're squaring the whole bracket, you're not just squaring the things inside the bracket. Okay, so question A is about reverse percentages. So in 2014 and 2015, well, let's have a look. So the sales went down between the two. So if we start off with 100%, and they went down 12%, what we left with? Well, we're left with 88%. Now, as a multiplier, and this is the best way of doing this, 88% divided by 100, make it a decimal, is 0.88. Now that number, 0.88, is what we times the 2014 sales to get 2015. But in this question, we're given the 2015 sales, so we're given this one here. So we want to work backwards. So what we want to do is I'll get my calculator, 7,359 divided by 0.88, and that gives me £8,362.50. You've got to ask yourself, well, is that reasonable? Well, they went down by 12%, so it's natural that they would go from a number around just over 8,000 to a number that's just over 7,000. So I'm going to write the answer, £8,362.50. Okay, the next question says that the sales went up in 2016, or they have a target to get their sales up in 2016. What's the percentage increase? Now, percentage increase or percentage decrease, it's the same formula, is change over original times 100. So the change, well, that's going to be 12272, take away the 2015 sales, so that's that one there, 7359. So they're looking for it to change by 4,913. The original was at 7,359, and we need to times by 100. So I'm going to divide that by 7359, times it by 100. And that gives me 66.7617, blah, blah, blah. So that's to the nearest percent, so that's going to be 67%. Okay, so I'm asked to complete the Venn diagram, and the E at the top I like to think stands for everything. So all of those numbers need to fit somewhere in this Venn diagram. And we're going to put the square numbers on the left and the odd numbers on the right. Now, there's different methods of doing this. What I like to do with this type of question is just do it one at a time. So we're going to start off with the 16. Now, 16 is a square number, but it's not odd. So I'm going to leave that here. 75. Now 75 is not a square number, but it is odd. So I'm going to put that there. Now 1 is a square number and it's odd, so that's going to go in the middle. 4 is a square number, but it's not odd. 28. Now 28 is not a square number and it's not odd, so that's going to go out here. 9 is a square number and it's odd, so that's going to go there. 93 is not a square number, but it is odd. And 2 is not a square number or odd, so that's going to go on the outside here. And I like to just add them up, find out how many numbers we've got in our Venn diagram. So 1, 2, 3, 4, 5, 6, 7, 8, and find out how many numbers we should have. 1, 2, 3, 4, 5, 6, 7, 8. So we haven't missed any, because it's quite easy with this type of question to miss a number out. Okay, so there's quite a few different ways you can do this question. I'm going to find out length CB, and then I'm going to, from that, find out length CE. So this question asks us for length CE. Now CE is the length that's shown at the bottom here. This is CE here. Okay, so that's the one we're trying to find. Now I'm going to first of all find out what CB is. Now what I'm going to do is just label this X, and I realise that it needs to be trigonometry because this is a rectangle, that's a right angle, so I'll need to use trigonometry for it. So we've got opposite and we've got the hypotenuse, so we're going to use sine, so SOH, so it's going to be sine 68 equals 27 over x, and I'm going to times both sides by x and divide both sides by sine 68. So that gives me x equals 27 over sine 68. And so if I do that on the calculator, 27 over sine 68, and that gives me 29.1204. And I just do a few more decimal places than usual because it's not an answer and you should never round your working out. If it's asking for one decimal place, I think 4 decimal places should be enough. But I'm going to try and keep it into the calculator if I can. So the next thing I need to do is work out CE. Now I'll need this angle here, which actually I can just take away 68 from 90 because it's a rectangle, the whole thing will be 90 degrees. So I'm just doing 90 take away 68, which is 22. So that's 22 degrees. Now I'm looking for this one, so CE. I'm going to call CE Y, and I've got, so what have I got? I've got the adjacent here, so this is now the adjacent, and I've got the hypotenuse because this is opposite the right angle. So this time I'm going to be using cos, so it's CAH, so cos 22 equals equals my 29.1204 blah 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 over y. So again, I'm going to times both sides by y and divide both sides by cos 22. So y equals 29.1204 blah 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 over cos 22. Now I kept that in my calculator, so I can just press divided by cos 22. Press equals, and it's 31.4074 blah blah blah. And it says it wants the answer to one decimal place, so it's going to be 31.4. Now, if I lost you a little bit because I went quite quickly through trigonometry, this is a kind of question you do when you're quite happy with trigonometry. There's loads and loads of videos on the site that go through right from the basics of trigonometry. If you want to do these questions completely within the trigonometry triangle, then that's absolutely fine. You'll get the same answer. Whenever we see a 3D shape in a question, you've got to ask yourself, is the question asking for a volume or a surface area? And that should be the first question that goes into your mind. Yes, it might be asking for something else, but those are the main two. We're looking at this, we're filling the swimming pool with water, so it's going to be a volume question. Now, way of approaching this is figure out what the shape is. Well, the shape is a trapezium-based prism. So we've got to first of all work out what the area of the trapezium is. So I'm going to draw the trapezium out first. And that height is going to be 2.7 that side, 5.3 that side, and 25 across. And I'll leave off meters because I know they're all in meters, but do check they are all in meters when you do this. So we've got to first of all work out the area. Now the area of a trapezium is half A plus B H. Now A and B are always the two parallel sides, and then the height is the one that connects them at right angles. So the height is going to be 25 there. And all you're doing is working out the average of the two bases, the 2.7 and the 5.3. going to times that by 25. Okay, so we'll crack our calculator out. 2.7. Some of you will probably see this straight away. So the first bit comes out as 4, because halfway between 2.7 and 5.3 is 4, and then times 25 is going to be 100. So the area is 100 meters squared. Now, for a prism, so volume, all you need to do is work out the area of the cross section, which is this bit here, the bit we just worked out, and then times it by how 3D it is. I think they call that the length officially, 15 meters. So the volume is going to be 100 meters squared times 15, which is going to be 1,500 meters cubed. So that's what the volume is, and it says the machine transports the water at a rate of 20 meters cubed per minute. So in 1 minute it's going to be 20, in 2 minutes 40. The other way of working this out, or the other way of thinking about this, is how many 20s are there in 1,500? So we can say time equals, so this is how much it's got to fill, and this is how much it does per minute. So on the calculator, 1,500 divided by 20, which equals 75 minutes. So it's going to take 75 minutes to fill the pool. In this question we're asked to compare two banks, and normally when I'm asked to compare something I just put a line down the middle of the working out, and I put one of them on the left hand side and one of them on the right hand side, and as long as it's identifiable which one is on the left and which one's on the right, you don't need to necessarily put the whole name down, but you can do. So I'm going to start with a super bank. It says we have 2.3% for the first year and 1.8% for all other years, and we're doing this for 2 years at £300. So first of all I want to work out what the multiplier is. Since this is the calculator paper, we use the multiplier method. So we start off with 100% always, and compound interest means we're gaining money, so we're going to go up by 2.3%, so that means we'll have 102.3%. So as a multiplier, what we do is we just divide that percentage by 100 to get it as a decimal into what we call a multiplier, 1.023. So if I times 300 by that, that will tell me what we have after year 1. So let's do that on a calculator. 300 times 1.023. And you might need to press S to D. And that is £306.90. Okay, so that's year 1, and we might as well just write year 1 somewhere. Okay, so year 2, we've got that £306.90, and we need to work out the multiplier for 1.8. So I could go through the same method as before, but actually when you start using multipliers you realise how to just go straight there. So it's going to be 1.018. But you could do 100 plus 1.8 is 101.8, and then divide that by 100. And what's that going to be? So that equals came out a bit wrong. So what's that going to be? So 306 and times 1.018. And that says it's £312. And I'm going to round this 42. I'm going to round it to the nearest penny. Okay, so that is Superbank. That's how much we'd get. Now, the Great Bank's a bit easier because it's just going to stay at 2.2. So let's work out as a multiplier. 100% plus 2.2% equals 102.2%. And then as a multiplier, that is 1.022 by dividing it by 100. So we're going to times that £300 by 1.022. So 300 times 1.022, and I get £306.60. Then I'm going to times that again by 1.022. So times 1.022, and this time I get 313.34. Oh, actually that would be 5 if I round it to the nearest penny. Okay, so it says which account will give her the most money. Well, looking at that, it's going to be the super bank. And when you're writing down an answer, make sure you write down the full name. Oh, it's not going to be the super bank, it's going to be the Great Bank. Look at that. So Great Bank Inc. And it says by how much. So I'm going to get that by how much. Let's show the examiner what I'm doing. So I'm going to do 313.35, take away 312.42. So 313.35, take away 312.42. And I get the answer of 93p. So £0.93. Now, if you hadn't have rounded both of those, you might get a slightly different answer. And actually, technically, you shouldn't have rounded them until you got the answer. But on a question like this, where you're rounding it to the actual money she would get, they wouldn't pay her half a penny, then either answer would be correct. And in this bit here, you could have done all of this just as one bit. You could just written 300 times 1.022 times 1.022 or times 1.022 squared. That would be absolutely fine because you'll get the same answer. Okay, with this question, the first thing to realise is that we have two similar triangles here. So we've got the smaller triangle here, and we've got the bigger triangle here. And they are mathematically similar because this angle is going to be the same as this angle because they're parallel lines, those are corresponding angles. This angle is going to be the same as this angle for the same reason, and this is a shared angle. So they're two triangles with exactly the same angles, therefore they have to be mathematically similar. And mathematically similar means all the angles are the same, but we've just multiplied all the lengths by something to get to the new triangle. So, important first step of this is to draw out the two triangles. Okay, and I'm just going to sketch them out roughly. So a small one, and we've got the big one. And then copy the length. So this is going to be 23, this is going to be 9, this is going to be 36 at the bottom here, and this one's going to be 60. Okay, now ask for the value of CE, which is this bottom length here. That's the bit we're trying to find. But I'm going to ignore that, and I'm going to work out what AC is. The reason for that is if I know AC, I can take away from 60 to work out CE, because I know the total distance is 60. Okay, to do that, I need to work out what the scale factor is. And the scale factor, all you need is a length on both of the triangles, which is corresponding, which means it's the same length, but on the two different triangles. And to do that, we do the big length. I say the same, it's not going to be the same length, but the same position on both triangles. So big length over small length. Okay, so the two I'm going to pick is obviously the bottom two. And we're going to find out what we times 9 by to get to 36. So 36 over 9. And that's obviously going to be 4. Okay, because 4 times 9 is 36. Okay, so we know we times that by 4, so the scale factor is 4. Now, if we go from big to small, we times it by 4. But here, we're going from, so if we go from small to big, we times it by 4. But here we're going from big to small. So instead of times by 4, we're going to divide it by 4, because it's going to get smaller, isn't it? So we're going to do 60 divided by 4, and I should really write down what I'm doing. I'm doing AC, and that's going to be 15. So we know that it's going to be 15 here, for this bit, okay? But the total is 60, and we're looking for what's left over. So we're going to do CE equals the total 60, take away the bit we know that we don't want, and that's going to be 45. So the answer is 45. Okay, I'm just going to write this out to make it a bit bigger. Now we're asked to make A the subject, which means we want A equals. So I'm going to put my lines down. Now the first thing I need to do is get rid of that square root, because if you look, the right hand side is all trapped in that square root. So what I'm going to do is square both sides. So we've got t squared equals, and when I square the square root, it just gets rid of the square root. Okay, next I need to get rid of that 3, so I'm going to take away 3 from both sides. So we've got t squared minus 3 equals 10a. Then I'm going to get rid of that 10. Now that's a times 10 there, so I need to divide both sides by 10. Now I could divide the t squared by 10 and the 3 by 10, or I can just write it as a fraction, which is a lot easier. So just put the whole thing over 10. So therefore a equals t squared minus 3 over 10. Now it's really important that if the letters are capitals, we keep them as capitals. If they're lowercase, we keep them as lowercase. It does matter what case the letters are, so if it's uppercase or lowercase. Okay, so we're asked to find the nth term of the sequence. So the first thing I need to do is work out what the sequence is going up in. So 9 to 22 will be 13. 22 to 41 would be 19. It's not the same. Okay, so that will be 25, and then this will be 31. Okay, so whenever you have a sequence that's not going up by the same amount, then the next step is to work out what the differences are going up in. The difference of the differences. Well, that's 6, and this one's 6, and this one's also 6. So if the difference of the differences is always the same, then you've got yourself a quadratic sequence. And the way of dealing with that is get the difference of the differences and always halve it. Okay, so we end up with 3. Now that 3 will go before an n squared. So we know our nth term will involve 3n squared, but we don't know what the rest of it is yet. So what we do is a little table, and we write in our sequence, which is 9, 22, 41, 66, and 97. And then we write down the sequence for 3n squared, which is going to be 1 squared times 3, okay, because n is 1 for the first term. So that's going to be 3. 2 squared is 4 times 3 is 12. N is 3 for the third term, so 3 squared is 9 times 3 is 27. N is 4 for the fourth term, so 4 squared 16 times 3 is going to be 48. And then 5 squared times 3 is going to be 75. Now what we want to do is take 3n squared out of our sequence. So if I call this sequence, we're going to do our sequence, and we're going to take away 3n squared from it. So basically what I'm doing is I'm going to do 9 take away 3, which is 6, 22 take away 12, which is 10, 41 take away 27, which is 14, and I'm just going to keep subtracting them. Now you might notice that we've got a linear sequence now. This linear sequence that's formed is going up in 4s. So each one is going up in 4s. And we find the nth term of this linear sequence. So we're going to have 4n, and then we're going to work out what the 0th one is. And I've not left myself very much room, and that's going to be 2. So our 0th term is going to be 2. So we know it's going to be 4n plus 2. So we put this bit here with this bit here, and that gives us our nth term of this quadratic sequence. So it's 3n squared plus 4n plus 2, and that's our answer. Now you can check this out by putting in 1 and putting in 2 and putting in 3 and seeing whether you do get 9, 22 and 41, which you will do. The easiest way I've found to work with bounds is just draw a number line, put the number that you've got, so we're looking at x, put the number you've got in the middle, try and figure out what the next number down would be, So the next number down would be 1.1 if then rounded to the nearest one decimal place. What's the next number up? Well, it would be 1.3. So the next thing to ask yourself is, where's the cutoff point? What stopped it from being 1.1? Why did it round to 1.2? So the lowest it could be is halfway between those two numbers, which is 1.15. So that is our lowest bound, lower bound. The upper bound, the higher bound, would be here, which would be 1.25, but we're not asked for that. So 1.15 is the cutoff point. Now this is a slightly harder question in B because we're given this formula here. Now we've got to be careful when we're using formulas. We're looking for the upper bound of t, so we're looking for t to be as big as possible. Well, for t to be as big as possible, x needs to be as big as possible because we're adding it and we want a number to be big that we're adding. But the bigger y is, the smaller that fraction becomes. So we want actually y to be as small as possible. If you ever think about it, the fraction a half and the fraction a third, which is bigger? Well, a half is bigger. So the smaller the number at the bottom, the bigger the fraction. Anyway, a little bit of a side note, but that's really important that you remember that if there's a denominator, that we want it as big as possible to make as small as possible number, or as small as possible in this situation to make the number as big as possible. So we need to find the upper bound for x and the lower bound for y. So using the diagram I drew earlier, 1.25 is the upper bound. Now you might say to yourself, well hang on, no, technically 1.25 would round to 1.3. Okay, let's delve into that a little bit. The actual answer should be 1.249 recurring, but there's two reasons I've not written that. The first reason is that it's a pain to work with. Typing that into the calculator would be a pain. The second thing is that actually 1.249 recurring is the same as 1.25. They are exactly the same number. Now if you don't believe me, a little bit of a side note, a third is 0.3 recurring, 2/3 is 0.6 recurring. Following the same pattern, 3/3 would be 0.9 recurring. But we know 3/3 is the same as 1. So 0.9 recurring is the same as 1. There is no difference, and that's very difficult to get your head around. Anyway, side note over. So the upper bound of x is 1.25. So we need to do a little number line to get the lower bound of y. So it's 4.6. So the next one down would be 4.5. So the cutoff point is going to be halfway, which is going to be 4.55. So that's going to be our lower bound, 4.55. So to find the upper bound of t, we need to do 1.25 plus 1 over 4.55. So let's just do that on the calculator. 1.25 plus fraction button 1 over 4.55. And I get the answer 1.46978 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1.47 because that 9 would round that 6 up. Now there's multiple ways of doing this question, there's loads of strategies out there. I'm just going to show you the method I do. I get the coefficient of the x squared, or in this case y squared, and times it by the number at the end. So that's going to give me 24. I then write down the factor pairs of that, which is going to be quite a few. It's 3 and 8, 4 and 6. And work out which of those adds together to make the coefficient of the y. So which of those adds together to make 11? Well, it's these ones, add together to make 11. I then rewrite it, but instead of that plus 11y, I'm going to write plus 3y plus 8y plus 12. So I haven't changed it, I've just split it up into 3y and 8y. Next, I'm just interested in factorising this bit, and then I'm just interested in factorising this bit. So I'm going to factorise the left hand side. Well, there's only a y that I can divide out of both of those, so it would be 2y plus 3. And here there's going to be 4, so 2y plus 3. Now if you've done this correct, the two brackets here and here should be the same, and you should end up with a letter and a number there. Now the blue ones go together to form a bracket, so y plus 4. And that other bracket that we underlined in green, we just write that once. So our answer to this question is y plus 4, 2y plus 3. And you can write it in any order. Now there's loads of different methods of doing this. This by far, for me, I've found is the easiest to explain and the easiest to do. But if you have a different method, some people do trial and improvement, just keep trying different numbers. It depends on how easy the quadratic is. When you have the coefficient of the x squared being a non-prime number, that can get quite complicated quite quickly. Okay, so we've got a linear and a quadratic equation, and so the way of doing these is slightly different. And if you notice that each equation has this y in, now y is going to be equal in both equations, so what we do is we just get the equations here equal to each other. So we've got 2x plus 11 equals x squared minus 5x plus 4. Now we can get them equal to each other because y, if we're solving, y is exactly the same thing. So we're just getting them equal to each other because they both equal y. And then we would need to get that, move that around so that we have e equal to 0. So we're going to take away 2x both sides. So we've got 11 equals x squared minus 7x plus 4. And we're going to take away 11 both sides. So we've got equal to 0, which we need quadratics to be equal to. So was it 4 take away 11, which is going to be 7, so minus 7. Okay, so at this point we're looking at either factorising, which I doubt is going to work, or using the quadratic formula. I think we're going to need the quadratic formula for this, so we need to remember what the quadratic formula is. So minus b plus minus square root of b squared minus 4ac over 2a. We've got a is 1, b is minus 7, and c is also minus 7. Okay, it's going to take a while. So minus b is going to be just 7, plus minus b squared, which is going to be 49, minus 4 times a, which is 1 times c. So it's going to be, and you can use your calculator for this. So it's minus 4 times minus 7, which is positive 28. So it'll be plus 28. Okay, over 2. And so 49 plus 28 is going to be 77. So we can rewrite it like this. Okay, this is where we split the two apart. We have the positive version, so 7 plus roots 77 over 2, and we have the negative part, 7 minus root 77 over 2. So the positive part, 7 plus root 77 over 2, is going to give us the answer 7.89 to 2 decimal places. Now, at this point, it's still in my calculator. Okay, I don't want to get rid of it because I need to also find out what y is. Now, it says y equals 2x plus 11. So y equals 2x plus 11, which equals 2 times this value in my calculator plus 11. So I'm going to times this by 2 plus 11. And it gives me the answer of 26.77 to 2 decimal places. And those are my answers for now. And y is 26.77. Okay, let's carry on. And I'm going to type that in again. So 7, but this time minus root 77 over 2. And it gives me the decimal answer of minus 0.89. Again to 2 decimal places. So minus 0.89. And similarly, we know that y is 2 lots of x plus 11. So I'm going to times that by 2, and I'm going to add 11. And press the decimal button, so 9.23. 9.23. And that's to 2 decimal places. So it takes a bit of time, but if you make sure you write this part here down, then you can just split it up into a positive and negative. So with this, it's an algebraic fraction, but just think of it as a normal fraction first. So just think you're doing a half plus a third. How would you do it? Well, you've got to get the bottoms the same. You've got to find a common denominator. Now the way we do these when they are algebraic expressions is just multiply both of the algebraic expressions together. So with a half plus a third, the common denominator would be 6, right? So you get that by just timesing the 2 and the 3 together. Now that doesn't always get you the best common denominator to use, but it will always work. It's just sometimes the numbers get a little bit big. So we're going to do that. Now whenever you see an expression in a fraction, always just imagine or physically draw in brackets around them, and that helps us. Now the common denominator between both of those is going to be just those 2 brackets. So what I want to do is times both of the left hand side by the right hand bracket, and times the right hand side, or yeah, you know what I mean, times the right hand side by the left hand bracket. Okay, so when I do that, I've got 3 times x plus 2 at the top, and then I've got x plus 5, x plus 2, plus 9 times x plus 5 over x. And I'll write x plus 5 first, just so it looks the same. Okay, now we can just add the tops now. So I can just add the tops together, and the bottom is the same, so I'll just write it once. Now I'm going to expand the brackets at the top, so 3x plus 6 plus 9x plus 45. Okay, now I need to collect the like terms at the top, and I'm just going to put this into my answer box. Now it might need it expanded, so I'm going to expand the bottom as well. So the bottom will be x squared plus 7x plus 10. If you don't know how to do that, see our video on expanding quadratics, or expanding quadratic equations, or expanding quadratic brackets. And let's collect the like terms at the top. So 3x plus 9x is 12x, and then 6 plus 45 is 51. And that's my final answer. Now in the exam, it doesn't always need you to expand. I could have left the bottom with brackets around it, unless it explicitly tells you to. So I think on the website for this question, it asks you to expand all the brackets. So if the question asks you to, you do have to. This is a question about iteration, and question A is a little bit harder maybe than the exam will go, where it asks you to come up with your own iteration formula. So, in order to do this, it says that fx equals 0 for this formula. So the first step is just to get it equal to 0. Now the question's given you a hint because it says that it involves a cube root. So we know that we're going to have x cubed equals something, and then we're going to cube root both sides. So I'm going to just put my lines down. And we're going to add x and add 5 both sides. and we're just going to cube root both sides. So our iteration formula is going to be the cube root of x plus 5. Now, with the iteration formula, it's a beautifully simple idea that this formula will, as long as we just keep ploughing in what we've found for the answer before, it will get us closer and closer to the real root. Now, sometimes the roots are infinite, so we could be sitting there all day and it will get a closer and closer and closer answer. This is why the question will say, oh, 3 decimal places or 4 decimal places. So that will tell us when to stop. So it always will give you a first one, okay, the x0, the first one to try. And all you're going to be doing is putting that 1 into this formula here. Okay, so let's try it. So cube root of 1 plus 5, and that gets me 1.81712 blah blah blah. Okay, now I need to keep that answer, so what I'm going to do is I'm going to press the cube root button, then I'm going to click inside the root, I'm going to click answer plus 5. And the calculator will remember the answer to the one we had before. Now, if you try and round them, you will get very, very different answers. And it might take you a little bit longer, or you might make a mistake. So you let the calculator do all the remembering for you. Then I press equals, and I get 1.89612, blah, blah, blah. So I'm going to do the same again. So I'm going to do the cube root button, answer plus 5, and we've got 1.9034 blah blah blah. Cube root button, answer plus 5, and we've got 1.9040 blah blah blah. Now we're looking for 3 decimal places, so the numbers we're looking for being the same is these ones here. Now, we've almost got them the same, but we're not quite there, so we need to do another one. So cube root, answer plus 5, and we've got 1.9041, blah blah blah. Now, even if you were to carry on going, the first digits, the digits I've circled with I've put a red square around, are going to remain the same. So as soon as you get 2 that are the same to 3 decimal places, that is your answer. So my answer is going to be 1.904. Now, obviously we haven't got it perfect, but if you carry on the iteration, you won't ever get anything different to 1.904. The only numbers that will change are beyond that. So that's why we can confidently stop now and say, yes, that's our answer. Okay, there's quite a few different ways of doing this question. I'm going to do this with a tree diagram, but you don't need to use a tree diagram for this question. I just find it a lot easier. So we're going to first of all understand that when you take 2 tiles, you can't take 2 tiles. You take 1 and then another 1. Okay, so you move away from this idea of being able to take 2. You can't. You take 1 and then you take another 1. So the first pick can either be an 8, a 10, or an 11. So it's an 8, a 10, or an 11. And then the next pick, well, if you pick an 8, you can pick another 8, a 10, or an 11. If you pick a 10, you can only ever pick an 8 or an 11, because there's only one 10. And then 11, you can pick any of the 3 again. Okay, so with 8, you can pick another 8, 10, 11. With a 10, you can pick an 8 and 11, and that's 8, 10, and 11. Okay, now the most important thing we realise is let's work out which outcomes will end up with the second tile. Okay, and we should probably label this. This is the first tile, and this is the second tile. So which outcomes end up with her having a larger one, larger secantile. Well, this outcome here, 8 and then 10, 8 and then 11 will. If you pick a 10, then you can pick an 11, and that's larger. And if you pick an 11, you can't get a larger secantile. So there's 3 outcomes you can get with this, with the secantile being larger: 8 and 10, 8 and 11, and 10 and 11. Okay, next we need to work out the probabilities. Well, all of the first probabilities are going to be 1 out of 7, because there's 7 tiles. Okay, so the chance of picking 8 is 2 out of 7, because obviously there's 2 8s. 1 out of 7 for 10, and then 4 out of 7 for 11. Okay, next, if you picked an 8, then there's only 6 left, and there's 1 10. So that's going to be 1 over 6. And I'm only going to be working out the fractions of the ones I'm interested in. So 8 and then 11. So if you picked an 8, there's still 4 11s left, but there's only 6 tiles. And finally, if you pick a 10, then there are 4 11s still, and there's 6 in total. Now, we work out the probabilities by multiplying the lines we went down. So let's have a look and see what lines we're going down for the first one. So we're going 2 over 7, and then 1 over 6. So it's going to be 2 over 7 times 1 over 6, times the tops times the bottoms. Okay, next line, we're going to do same line down here, but this time we go down here. So it's going to be 2 over 7, but this times 4 over 6. So that's going to be 8 over 42. And the final line, we go down the 10, and then we go down the 11. So it's going to be 1 over 7 times 4 over 6, which is going to be 4 over 42. Now, whenever we've got multiple outcomes, and it can either be this one, or this one, or this one, we add them together. Okay, so the probability is 2 over 42 plus 8 over 42 plus 4 over 42. So 2 plus 8 is 10, plus 4 is 14, so it'd be 14 over 42. And if you cancel that down, 14 over 42, you can half top and bottom, half top and bottom, and then I think you can divide them by 7, so you get 1/3. So the answer is 1/3 chance. Okay, to answer this question you need to understand the sine wave. And the sine wave starts at 0 and then goes up to 1 at 90, goes back to 0 at 180, down to -1 at 270, and then back up to 0 at 360. Now what's happening here is we're taking away 30 before we put it into sine. So at this point here, sine thinks we're at 0 because that point there is 30. So we're going to do 30 take away 30, which is 0. Sine thinks we're at 0, which it will spit out the 0 as the answer. Similarly, at this point here, it's 120. We're going to take away 30, which is 90, so sine thinks we're at 90. So all the way along here, sine thinks that we're kind of 30 to the left. And so it will be very similar to a sine wave, but it will just have moved to the right. I'm rubbish at drawing these. That was really poor because that went up too quickly there. And this is kind of a stretched out one. So we're going to go up to here, then we're going to go back down to here. Now notice that it doesn't start at 0, it starts somewhere, and I've estimated here, somewhere there, and it doesn't end at 0, because it will go back to 0 at 390, because then we'll do 390 take away 30, which is 360, so it doesn't end at 0. So the rule is that if you minus something within a function, then it moves right by that amount. And it's counterintuitive. You'd think if you take away 30, it will move left 30, but it goes the other way, and hopefully I've explained why. To be able to answer questions like this, you've got to be able to sort of think in 3D. So try and imagine that this box is sitting in front of you. You're asked to find the angle GEC. So if we go from G to E to C, then we're being asked to find this angle here. Well, we know to find an angle, we're probably going to be using trigonometry. And at the moment, we only have one length. We have that 11 centimetres at the end, which will be the opposite. So if I mark that, that's the opposite when we use trigonometry. Now, the hypotenuse is not something we can easily find. So the hypotenuse here, well, we can't really easily find that. So that's probably not what one that we're going to be looking for. But the adjacent at the bottom, if you have a look at the bottom, the adjacent here could be quite easy to find, because if you have a look at the right angle triangle here, we have two of the lengths. We've got the 5 and the 6, and we're looking for the third. And because it's a cuboid, we know that that's a right angle there. So the first thing I would do to start this question off is just copy down the triangle that we've got at the bottom. So it's 6 centimetres and 5 centimetres, and all of them in centimetres, so I don't need to put the units just yet. Okay, so to do that we use Pythagoras. So we're going to square them, add them, and then square root it. And we call this EG. There's line EG, not for example. So, I mean, we can use our calculator for this. Root 25 plus 36, and that's root 61, and we can leave it as root 61 because we don't want to have to round it at this point. Okay, so the next thing to draw is the right angle triangle that the purple one that we've got on the diagram. So let's start drawing that. Whoops. Okay, so we've got A at the bottom, which we now know is root 61. Let's scroll down a bit. And the height is 11. And we're looking for this angle here. And we can call this angle X, why not? Okay, so to do this question, we need to label the sides first. So that's the opposite and that's the adjacent. We need to just quickly write SOHCAHTOA so that we can check which one it's going to be. And it's TOA that has the opposite and adjacent. And so we're going to write down tan, and we called it X, equals opposite over adjacent. Tan X equals, well, the opposite's 11 and the adjacent is root 61. And we're going to inverse tan both sides. Just standard trigonometry. So inverse tan and fraction 11 over root 61, and just close the bracket. There we go. And it says that X is 54.62438 blah blah blah. It says it wants its 2 decimal places. So the answer I'm going to write is 54.62. Okay, so we've got a cubic graph here because it goes down then up and then down again, and we're asked to find the equation of the graph. Now the problem with this is the normal method is to put down 3 brackets and any solution it gives us in the graph we write down the opposite, the inverse sign, right? So for this one here, it would be x minus 6, because 6 take away 6 is 0, therefore that's a solution. And for this one here, it would be plus 7, because 7 take away 7 is a solution, right? Because it equals 0. But the problem we have here is we've kind of run out of solutions. And therefore, the natural thing is to think, well, maybe it's a quadratic. but we can see it's not a quadratic, it is a cubic, so it needs to have 3 brackets. And not all cubics make 3 brackets, but this question will. So we've got to think, well, hang on, we actually have 2 solutions here. We've got the down solution and we've got the up solution. So that actually represents 2 solutions, not 1. And if you have a look at here, we've just got 1 solution because it just goes through once. So when it turns on the axis, it gives us 2 solutions. So there are 2 lots of x plus 7. So a bit of a unique situation, that, but it's useful to remember. I hope you enjoyed that video. If you did, please click like, and if you really enjoyed it, please click subscribe. Also, make sure to check out our website. Our website has a lot more on it, and you can just revise anything you want. Finally, very, very good luck for those of you doing the resits in November, and I hope you get the result you want. Thank you very much.